Hello, today we're going to be doing the question from 2019 Unit 2, question 2c. So a converging lens is used to produce a real magnified image as shown in the full-scale diagram below. So by completing the diagram, we're going to be drawing a ray of light that will allow us to locate the principal focus of the lens and therefore marking the principal focus. So we know that from the top of the object, there's going to be a ray which travels parallel to the lens. So there is that ray. Let's always remember that we need to mark the arrows of to show where the light is traveling. Then there will be a light going from the top of a light ray going from the top of the image to this ray. Okay, that's where it converges. So we're also going to put an arrow in to show that's where it is. The point at which it passes the axis, which is right here, is going to be our principal focus, and we're going to call that F. There is another line which passes undeviated through the optical center. Sorry, that's not very straight. It goes through the optical center and meets the top of the image. Okay, so that line is also there. Didn't ask us to draw that, only asked us to draw the first line, but there it is. Okay, so measuring the focal length in centimeters, this is full scale, and I think each of these boxes is 1 centimeter. So we're going to say 2 centimeters, sorry. It's jumping about me a bit there. 2 centimeters, not 1 centimeter, because it's 2 of these boxes. Okay, so what application can we use this lens to produce the type of image shown in the diagram? So this is a magnified image, and it is real, and it can be projected onto a screen. So one application we could use is a projector in a movie theater, or for old-fashioned slideshows. We're also going to do the next question. A person suffers from short sight. How does this affect the person's vision? If someone is short-sighted, they can see things that are near them. So distant objects are blurry. It's something that I have a lot of experience with. So distant objects are blurred or out of focus, whatever way you want to show that. So we need to complete the diagram below to show how a lens corrects this problem, okay? And we need to write the type of lens used to correct the problem in the box. So we use a diverging lens here, and the diverging lens is drawn with 2 arrows on either side. They're pointing in, and that sort of denotes the shape of a diverging lens, which goes like that there. It's curved inwards rather than outwards. There's also a lens in your eye. It's always a converging lens in your eye. And what happens in short-sightedness is it over-converges, and therefore the point of focus is not on the back of the retina where it should be. So we want to correct this, and the way to do this is we diverge the rays. So here are the rays diverging. 2 rays diverged after the lens, and then they meet the optical nerve right at the back of the retina. So those 2 points are meeting there. Okay, and that is the diagram. Okay, we'll not do refraction, we'll just do lenses. So let's check these answers. So the first one, if we go on to, because it's always good to see what the mark scheme tells us to do. So this is right here on question C. So the ray from the top of the object parallel to the axis passes through the lens to the top of the image. So here we have this. We've got the ray from the top of the object traveling parallel to the axis and then going through to the top of the image, which, if my tablet cooperates, okay, it's not going to let us slide it across, but that's fine. Goodness, really jumping about. That was question 2. There's here there. Okay, and it's measured at 2 centimeters. There's that answer there, and projector is the right answer. Okay, so here cannot see distant object clearly in focus or appears blurred. So we've said distant objects are blurred. That's correct. And then correcting the diagram, the rays diverge from the lens to the eye. We've drawn that in, and then the rays converge in the eye and meet on the retina. Okay, and it's a diverging lens. So those are the answers with the mark scheme. You can kind of see the kind of things they're looking for there. Careful to look out for. You need to mark the focus on this lens diagram, which we have with the F, and you also need to put the arrows in to show the direction of the light. Those are things that are really, really easy to lose marks on. Okay, thank you.